Next on stage is Tine Vandenbreeden. She's COO at SAP, and what you probably don't know is that she has a digital twin sister. As a matter of fact, we soon will all have a digital twin. And Tine, please tell us, how smart is your digital twin exactly?
Thank you, Nela. Thank you, Nela, for the nice introduction. Fellow data scientists, data warriors in the room, listening to the presentations this morning, I want to bounce a few ideas against you on big data. Not only on my digital twin, but on big data in general, and how I believe that big data can and should become smart data. Before I dive into some examples, first maybe, slowness, as we learned. First, maybe show a few concepts that I want to build upon. It's all around us, digital transformation. It's the big buzzword everybody talks about, all my colleagues talk about today. That's fine. But let's deep dive a bit into that. How did that happen? Where does it come from? Digital technology today is all around us, and it's much more feasible. The smartphones you're using, all of you right now, did you know that on average, this thing has about 14 sensors built in? You probably know also that the car you're driving has also some sensors. Looking into that with some of our customers, it's now much more easy to build in these sensors into cars. It's feasible, but it's also much more affordable. Looking at the same car builders, we noticed that building in that car sensor right now is 300 times less expensive than it was 6 years ago. Looking into that same area and talking to Materialize. By the way, if they're here in the room, I want to congratulate them again on winning the Trends Gazelle, fastest growing company national this year. Materialize is a 3D printing company. They have informed us that the 3D printing over the last 6 years became 400 times less expensive, so also much more affordable. And last but not least, working at SAP, we calculated that overall computing has become 600 times less expensive over the last 6 years. So it's much more feasible. We have all these sensors, IoT, machine learning, the robots out there with us. It's much more affordable. Fine. We noticed over the last year that it also became much more viable, realistic. The result is already there. Looking into the manufacturing environments which we operate, we noticed that our manufacturing customers have 40% less costs in maintenance today than they had a few years ago, 40% less. We noticed in innovation areas that it takes half the time to have a new innovation, a new product being brought to the market. We noticed that technical professionals, just like you, have become 55% more effective in the work you do on a daily basis. So it's working. That is what digital transformation is all about. Fine, it's out there. Second statement which I want to bounce off to you is not my own, but comes from Gartner. Gartner sees in IT a bi-modal system, 2 types. First model is the one where we work, or where IT infrastructures companies work on a very reliable, stable infrastructure that runs their business. Probably you know SAP in that area. One central system running on one set of data, guided by business processes and best practices that optimize these business processes, helping companies, helping IT departments to run the company. That is one element of the Bi-Modal system. The other, the holy grail today, is innovation. Having new stuff being developed to have a competitive advantage. Making every company become now a software company. And building these applications we just talked about that allow to do it different, to make a change, to use the innovative, feasible elements which we have there, the technology. New ways to engage with customers, new ways to sense things, to capture data. We at SAP, we believe that it's not the one or the other. We believe that it needs to be the combination, bringing them together, that brings the real competitive advantage. Having this digital core, this base element, running the processes with the innovations included, extended, enhanced. That is when I believe that big data coming in via the sensors, via the robots, what have you, combined with business processes, big data becomes smart data and can actually give competitive advantage to companies and can help the world be run better. A bit too conceptual? Okay, I take that. Let me give you 2 examples of what I mean with that. The first one here is about wildfires, tornadoes. It's a natural phenomenon. I mean, you probably see that in the news, which is coming up more and more. It has quite a big impact, financial, on companies, but also on people, on people's lives. And it's across the globe. Some people make a business out of analyzing these wildfires, these tornadoes, these natural phenomena. One of them is Munich Re. Munich Re is a customer of SAP, and they are a reinsurer. A reinsurer is a company that insures the insurance companies. So they take the big risks when something happens like that. They have about 40,000 people around the globe working for Munich Re. Out of them, more than half of them data scientists. I checked this morning on the web pages, 152 open vacancies. So next thing you want to do is go and have a look down there. A lot of data scientists working at Munich Re were analyzing historic data based on the analytical models that they had in-house. They could look into the causes, they could look into what was happening around the globe, but they got stuck. They only could look at this based on on data coming in. That's when, together with SAP and with ESA, the European Space Agency, they thought about a new model, a new, smarter way of working. What did they do? First of all, they looked at the SAP World Observation Service, which is an application that allowed them in one view to have a global overview of all the events happening, all the wildfires, all the tornadoes happening similarly at the same time, with same root causes, etc. They enhanced this data with the data coming in, geospatial information, sentinel information coming in from ESA, from the satellites. Climate changes, land use, movements on the ground, all that stuff. By combining these, they now actually do not have to look only at historic data, they can do and go in a predictive mode. They can actually try to prevent natural disasters from happening. They can inform governments, cities, people of the events that will be coming up. And you can imagine Munich Re also, of course, has a big impact on their company, on their profit, on their company results by that. So what happened? They took data, big data, and they made it into smart data by combining it with business processes that they used in the past, by having analytical models which they already used, enhanced with new sets of data available. As you can imagine, there is much more use cases similar like this. Think of the farming, digital farming, what that could mean. Think of having maintenance of big oil pipes done in a predictive way. Think of the smart cities. Lots of projects on that today. Second example is about my digital twin, as Nele explained to you already. Second example, and I really like that one, is the Arctic Winds company. Arctic Winds is a company that operates windmills, reusable energy. They don't do that here at the North Coast. They do that high up north. They have the most northern wind park on the planet. As you can imagine, it's not fun to go over there and do the physical inspections of the windmills. It's quite expensive, dangerous, it's quite cumbersome. So that is the biggest cost for Arctic Winds, that is to go to do these inspections up north. They are a customer of ours, and they approached us asking to help them to reduce this maintenance cost. That is when we decided to build a virtual twin for each of the windmills up there. We used FEDEM, it's an acquisition by SAP of quite a while ago now, which is specialized in having the virtual reality in real time, operated in real time, visualized in real time. So FEDEM built a digital twin for each of the windmills there. The data coming in from the real windmills, from the sensors over there, is captured in that system and is visualized in real time. This allows the operators to do and to use the events happening on the structures there, to use these events to start checking how the windmills are actually behaving. If they are behaving as they were originally designed, if there is damage by extra wind, by, I don't know, aging being done, and how the systems are behaving. They can also, and they monitor that and visualize that real time. They can also go rewind and go back in time, and they can replay, for example, a heavy storm and what that did on the mill, on this virtual twin, on this virtual model. We help them by putting SAP sensors, virtual sensors, you still following me? Virtual sensors on the virtual model, doing some deep dive analysis and identifying root causes, working also as well in a predictive way. Second example on Arctic Winds is about, before I dive into this, is about, that went fast. Okay. Murphy. Second example, Arctic Wind, is about how big data coming from these sensors in the virtual twin is actually becoming smart data, allowing Arctic Wind right now to build more wind parks across the globe in even more remote destinations, powering us all up here with reusable energy. So Munich Re, Arctic Wind, two examples. What's the magic behind it? There is no magic, there is no golden hammer. Thank you for that tip. But it is a platform, which I believe is the digital transformation platform that supports these kinds of use cases. Three components that I want to highlight. First of all, you need the digital core. As I said, you need this business logic. You need this digital core system that allows you to operate the processes. Secondly, super important to you guys, you need business objects, you need analytical capabilities. Business Objects Cloud, and we have with us today the digital boardroom where you can visualize an operating system or an analytical system across your organization. And thirdly, the cloud platform. That is the model 2 that I explained. This is about adding innovation, building new applications on the cloud platform that can enhance the business processes, that can enhance your core system, that can build new applications that give a competitive advantage like we did for Munich Re. These three components for me are the digital platform that allow to have the big data, all the technology innovations which we have out there being built into something smarter, something that can actually help companies to run better, can help the world to run better. Yes? In my last minute, I want to encourage you. I really want to ask you to go out there and learn more about the use cases that I just shown you. Online, you can find more stories from other industries, stories that bring the digital real, that bring it to life. I would also like to encourage you to start playing with it. I was recently at a very successful hackathon in Antwerp, where a nice company, the Compagnie van Verre, don't know if they're here with us today, learned to use the HANA Cloud Platform, the SAP Cloud Platform, in only a few days. They put their hands on it and they built some magnificent new apps which they would love to show to you. So let you be the next Compagnie van Verre approaching us. And last but not least, please approach us, connect, either with myself online, the people here from SAP that can help you to further understand this in detail. Connect to us and share with us, because I'm really sure that there's many more smart ideas here in the room on the projects you work on. The technology is there, it's feasible, it's affordable, the business logic is there, so together we can make this world run better.